There we go. And I don't know if you guys use it, but I got the, also have those, I had to move them. No, the class recordings. So I had to move them up to Google Video.
What is class recording?
Any classes that I record, I put up. So.
Maybe this. Oh, that's right. I totally forgot about that.
Yeah. So there's another one that's processing. I don't know why, but so basically, if you want to refer to code um, in any of the wiki pages, just link to a page, but pick the exact version, because if you pick the exact version, it'll actually go directly to the code, to the whole code. Whereas if you choose like some of the tags and stuff, it'll just give you the release history and everything. So if you want to refer to the code, just refer to the version and then just swipe the URL and put it up there, and it follows a pretty straightforward. Right? Everything is built from this is the main repository, and then paste your project and then the path, and then it'll have the rev up there. So if you know the rev, you can just type it directly in. But that'll keep some of the code off the wiki, but basically just link to the code and then discuss what you want to discuss on the wiki. Like, or if you want to say stuff about design, and then hopefully eventually we can migrate that stuff into Java docs on inside the source code so that we can build reference for the whole code. Okay, so what I want to do first is just kind of go over some of the code base, like on okay. So the first thing is I guess are we going to package inside parameter sweep? Rhea, I noticed you moved it into parameter sweep from. You're having trouble linking? Oh, okay. See, we can do that. So what I did was I updated the XML file. Let me get two windows open here. Um, also, you'll know since I got my MacBook, I'm migrating my stuff to Xcode, so you'll see some Xcode stuff in there. You can just look longingly at it. So I updated. Oh, actually, I have to go to the version. Okay, so I updated the what are the arguments for that? Oh, you can even do plain text if you want to do your links like that. But so now we have to specify the module inside. The only reason I moved it to the default package before was it was just easier to reference everything, and since it was isolated in a jar, I figured there wouldn't be any namespace problems. But we'll see which of these ends up being more convenient. But just keep in mind that we have to keep these two things in sync. So whatever Java would reference that particular class as, we need to make sure that the XML file reflects that as well. Now, one thing that we do have to decide on is how we're going to get initial parameters into the program, because, like for example, with Input Factory, we need some initialization numbers in some way, whether it's at construction or at some other time. We need some way of passing in parameter applications. So the idea here is, if we think about the kind of use case of these applications, there's some dude sitting at their computer and they want to do some big computation, right? So they say, okay, I got this big computation. I got a bunch of friends or whatever. I got a bunch of volunteers that may or may not want to help. Okay, so what can we do as far as launching an application from up here, and then everybody just kind of starting to participate? So the first thing is how would that person kind of initiate an application? Okay, so the idea here is we have this paste jar that's built on its own, right? And then we have we're obviously going to need some application-specific code. So the idea is that they'd fire up NetBeans. They wouldn't have all the source code to paste necessarily, right? They just have the paste jar, right? So then they should be able to reference that, write a bunch of code that derives off those objects, and then have a working application. Okay, that working application should then be able to. They should be able to compile that into a jar, right? And take that jar and maybe some other stuff, right? And load it into their paste client, and then people should just start working. Right? So right now what I'm doing is I'm passing a command line argument in. So you just run paste with an XML file, because the XML file, along with anything else it references, is an application. It's like loading an application into the paste operating system, right? So we kind of got to decide, how does that look? So right now we have a basic XML file here, which just has the jar itself and then some modules. Okay? We probably want to get this down to the point of just being a jar. I don't know. You know, where you load a jar and it has the XML file or parameters or whatever in it. Okay? And I don't know if, the XML file for which modules we want paste to load, that's basically, that list is which modules should paste instantiate when it loads, when it starts to run this application. Whether we want that built into the objects themselves as well, I don't know. Like if there's a way for Java to just query everything in a jar and have it report back whether it wants to be loaded or not. I think that might just be cumbersome. It's easy to just pop some names into an XML. So ideally what we probably want here is that if I'm going to run an app, it might get to the point even that we don't even have to write the app, right? Where there's an app out there that, say, does, clustering or something, right? Where you could take the clustering jar, right, that jar file that is the clustering application, and then just modify the XML file and then run it. So we need parameters there. So the idea is this: do we just put parameters into the XML file? Do we just say, like, have like a parameter? Do we just have a parameter list? We'll call it start value 0 type of thing. And then do we report that to everyone? And do we want to create a mechanism that can actually instantiate these objects using those parameters? Because see, right now, I think how you have for example, input factory. We have this. We have the start and end in the constructor, and then I put in my kludge for now to just so that I can instantiate input factory, because this actually runs right now, which is surprising. It actually it'll do 10 iterations if I run this. I don't know if any of you have tried running it yet. Java jar this paste. Let's see if it runs right now. Oh, it runs if you don't break it like I did. Hold on, let me revert that. Discard changes. And what other thing did I break? Project properties, discard changes. Build. Done building, succeeded, yay. Okay, so this is, it loads. This is the load. Okay, also notice the command line that I used there. Right, I'm doing the Java jar paste, which is just running it, and then I pass the command line argument of the XML file I want to pass. right? So source is where it's stored, and then just XML. Okay, so it's loaded, and now it's just sitting there waiting for events. Okay, one event I can do is quit, Q, no fun, right? The other event I can do is start, which is S. Okay, so then it stops at worker got generate unit, generate work unit, because that's my sample worker. Because we don't have any other worker checked in yet. Sitting on the desktop, I just forgot to hit CVS commit. It's all working. It's just I forgot to hit CVS commit. No, but yeah, check something in. You know, no matter how much it works or not. They're 10, 11. Oh, 0 to 10. Yeah. So works. um, and interestingly enough, if everything worked right, that worker, the basic worker class that we have there, that should have um, this signal would contain the result units inside it. Okay. Now, on that note, let me give you just some tips here as far as what's that? Result units. No. You're right. Work unit. Worker generates result unit. No. Well, this event would have work unit in it. An event that worker generates would have result unit.
Yeah.
But okay. So with that in mind, you'll see I updated some of your methods. Read with all I did was I shifted your use of, where is it? Right here. Yeah, like no. Better event would be like split. No, like absorb. Absorb absorbs an input factory, right? So what I did was before you had input factory as the argument, I just changed the argument to event, and then I pulled it out and casted it so that now you're back where you started as far as if it was being passed in as parameter. So most of the style of these use of event should be this way. So however you intuitively would write that method with its parameters, just shift it down one and then pull it all out of the event. So if you have a method that you're thinking of that has multiple parameters, put all those multiple parameters in a collection and then parse out the collection at the beginning of your code. Okay? Ideally, we also want to put type checking in here because in the events we are passing a string which represents the type. Okay, so ideally either in the catch, in the abstract object with the catch, we just set up all our signal our slots to know what type that their event should hold when they're catching it, and then we could have catch do a generic type check where if it gets an event, it can look at the type and say, oh, this isn't the right type. Somebody made up a silly event or something, so I'm going to just let it go, type of thing. Or if it's correct, then we will then pass it down to the method. Okay. So does everybody get this mechanism? Okay, and then everybody seems to have caught on to like the idea of just emitting instead of having a value come out using the return. Okay. So in fact, even if you do have these methods that do have returns on them, unless you're using that somewhere else in the object or whatever, like you're using this method to do stuff, you don't need it. Void, it's not going to. What's that?
I basically, instead of returning everything, I just changed what my returns to booleans.
Right.
So
Yeah, to get it out of the way.
If we don't have to catch it, no, it's the whole.
Right. No, that's what I'm saying. Is you can use them. You can have whatever you want to return. It's just whenever we're calling it, we'll be calling it strictly with just that and throwing away whatever happens. Oh, actually, I don't know if I do catch. Either that or they're all booleans. I don't know if I do a true-false check on calling the methods when I do a catch. I'd have to check an abstract object. So let's see that right now. Worker. Ah. Abstract module. So, catch, emit, oh, it's actually in, oh, here we go, catch. Yeah. So I just call it directly with no return. So you can return whatever you want, and again, that might be convenient if you use the method internally or whatever, and you want to use it for other things. But just keep in mind that the signature of what it's passed in needs to be the same, which is event, which is take a pace event as the argument. Okay, because I'm going to pass that in as the only argument to any method that I invoke. Okay, so we do get a start, and on a start we call generate work unit. So just actually also real quick, let me show you why we got a start. I'm going to do that every single time, aren't I? Okay. So in start, you'll notice what I do is on this input there, I create like a really rudimentary event queue, okay, which is it's just a signal emitter, and all it is a loop that just looks for a character, and then I emit signals. Okay, so I put in all the stuff that is for that is needed for necessary for signal emitter, and then I come down here and I just look for events. So when I hit start, when I hit S, right, I emit a start event, no parameter, and null. Okay, so then that comes along. Generate work unit was set up as a start slot, right? So start generate work unit. So it calls generate work unit, one instance of it, and what it will do is it'll check its queue, go through generate a work unit, right, and give it all its values, and then it will emit that work unit. Okay, and then the abstract object in the abstract module, what it will do is it'll take these strings, instantiate a new pace event, and then put these values in there. Okay, and then we also have an extra emit. You say so you have some signaling going on between.
That's for consolidator. Like once the track work can't emit anymore when it fails, basically.
Okay.
Do it just says consolidator stop, and then that was gonna be the queue to like dump your information back.
Okay. So yeah, we'll have to see what the kind of the overall kind of ideas, because we'll probably have to tell some of the other objects some things too, like as we get through this. So then on consolidator, do you have some other things where it will, if it catches a consolidate, it'll what?
If,
it'll get one more work, or
like if it catches a consolidate with a result unit, then
that's the final one?
no, if it catches one with one, it'll just keep going the roll. If it catches one without, then that's the signal.
Oh, okay. So if it sees a null there,
Right.
it'll say that it's done. Okay. So this is a final consolidate that comes out. So should that be an else? Oh, because it returned true. Okay, so it'll never get hit if it. Okay. Um, okay, so if it sees one of those, you're simulating the consolidate that worker normally emits, or
Yeah, worker.
well, this should well. Who normally sends the consolidate signal? Consolidate normally sends the consolidate signal. So this should actually be a work, probably, right? It's because you want to pretend like you're the worker. The worker's not going to emit a new result unit because it's done. It never gets a thing. Okay, yeah. So I see. Yeah, that's a good signaling mechanism. So yeah. So okay. So let's see what else here. Oh, this is all old stuff. Okay. Right. That's the other thing. So from here on out, we don't need to really save code anymore. So if you ever say, "Oh, I really wrote it better the last time," then you can just go back in CVS and. Actually, I was really surprised with how good NetBeans handles CVS. Like you can go through the history and search and all that stuff. So it seems pretty good integration. And you don't have to download CVS if you're like on Windows and stuff. So it works out pretty well. Also, is everybody now logging in with your separate accounts for CVS? Okay. Okay, and the new one, there should be now an account called Richard, and the login is Richard P2P. So just easy. I mean, I didn't know of a good way to change your login on all the CVS. I mean, you can do it. All you have to do is go to the CVS root and all the CVS directory and all your subdirectories and change the repository. It's easy to just wipe it out and then check it back out. So check in all changes that you might have, get out of it, wipe it out, and then re-import everything from CVS. So, but when you do the checkout thing, just put in your new account. Okay.
And it's
Richard, and the password is Richard P2P.
Did you send them an email?
Yes.
I don't think I got that email.
I don't think you're getting any of my emails,
No, I
Richard.
got one of them because they responded to it, wasn't it?
Yeah.
I got the one where you gave the generic.
Yeah. And then there was one after that. So then what I did was I took all those
Oh.
and then I forwarded those in another email. Like so, I was using your Yahoo one.
Yeah, that's the one I use.
Okay. I must be spam then or something because or they're like there's a plot against Gmail accounts on Yahoo. Okay.
That might be true.
Yeah. So all right. So next thing that we're gonna see, right, is this not happening anymore, and worker is instead going to emit a new signal, which consolidator will catch. Consolidator will then eventually get to the point where maybe I don't know, it needs to get to a file or something, or it needs to get to something we send.
For worker right now, I have it set up. I mean, I have the code on the wiki. It's not on CVS though, but I mean, it's pretty much how it was when we first, or I don't know, before we set it up with pace with the signals. Except now it handles the signals.
Mm-hmm.
Except it's not returning the result unit yet because I guess I don't know. I kind of briefly talked to you about it the other day about how worker is going to handle. I don't know if I was confused on how worker was going to actually, where it was going to get the, how it was going to do the work. That's user defined, right? That'll be specific to whomever uses our app, right?
Wait, what now?
Write their own jar, and then the worker would load that jar and whatever.
No, the worker is just for this app.
Oh, okay. All right. See, that's where I was confused.
Yeah. So you're not going to be
That's
parsing.
why I was like, well, if Sax loader's in there, I'm going to need my own to find out. Okay. All right. Never
Yeah.
mind. That makes
So
sense.
once workers are already in the world of the parameter sweep app.
Okay.
So the idea is everything in this branch. Hold on.
Specific to
Yeah, you can be as specific with the objects as you want from here on out inside parameter sweep.
Okay. See, cool. That's why I was like talking about that because I was just, I don't know. I guess I wasn't paying attention.
So before your other statement where you didn't know if you were confused, you were definitely confused.
Yeah.
So we've answered that particular question. So now,
okay, so now
the real
tonight I'll have it how it should be. Oh.
right. So okay. So and that's the idea. Is the whole point of this is that programmers want to be specific with their data and objects and things like that. They want to be able to just say it looks like this. I can do operations on it and whatever. So what we're doing is we're giving application writers that freedom, but then everything at the border, right? Everything that goes in and out of that border, we're making sure is completely isolated. Okay? So they're not going to have access to any of that. So the next step, well, still part of these steps is we need to nail down what's going to be in this XML file. So we need the offsets and bases, right? We need that somewhere in here. So we need to put in offsets. You know what? We'll do it all in the wiki. Oh, you're going to have to wipe it out and then go back into CVS to checkout, and then it should be in there. Okay, so we actually need a new thing, right? Because we need the XML file. So I don't think I have that really anywhere in here. Oh, I need a faster machine for my web server.
Is the back end for Wiki just like pretty complex? I mean, the rest of it.
No, it's actually really. It's just. I mean, it's a database, and I mean, there's just a bunch of PHP pages. I don't know. This is apparently the same one that this media, P2P Media Wiki or whatever. It's apparently the same thing that that Wikipedia uses. It's the I think it's the same engine. The only thing that they have like some sort of like support for some sort of accelerators. Like it does probably some like efficient caching or something of all the pages. But this is from them. I mean this stuff. So it's pretty. I don't know. It's pretty neat. So application configuration will be handled by the parameter sweep XML, right? Parameter sweep.
What about like for Jigsaw stuff like the group and that type of stuff? Where would that go?
That's going to be in.
Okay, so you actually want.
Now there's going to be two aspects to that. There's going to be two aspects to that because the idea I think is that we have the net peer group, which will just be anybody using using this. I don't know if we want to create a subgroup for PACE applications and then application groups under that, or we could just use the net group. I think what we do is this: we have the net peer group, which is the generic Juxta net peer group. Okay, Juxta is an overlay network on regular networks, right? So what the net peer group is everybody who's running Juxta. So then we'll create another peer group over that, which is a PACE peer group. That's everybody running PACE. And then over that, we'll have a peer group that is the parameter sweep app, for example, right? And then if because what that's saying is you can run PACE, you might be participating in this parameter sweep app, but if you're not interested in all the fabulous science that's going to come out of the idea of adding two numbers together, right? You're like, I don't know, that just doesn't seem like a worthwhile project. You can go do something like, I don't know, like curing cancer or something on another project. So the idea is that you'd be able to create these individual app groups on top of that. But I think there's going to be a related aspect to that as the application group being somewhat handled in the jar. But no, actually I don't think so. I think that's going to be handled in PACE. Because what you'd be saying is this: I want to create an application group. The application group has nothing to do with the actual code you're running. It's just saying we're trying to compute something. We happen to be using a particular set of code. So in this app group, I'm going to advertise a service or whatever that is actually running this jar with this XML file. So it's not going to actually be related to the jar itself. So okay, so parameter sweep XML. What's that? Past tense XML. Conjugated XML. Alright, so yeah, I really need a faster machine because I've forgotten what I was going to put in there at this point. Yeah, what we need to add. Oh. Alright, so we need, right now we have the modules, right? The program modules, or oh, we have the jar and the modules. What am I in? Parameter sweep. PACE, okay. Source, XML file. Right now I have the path and the modules themselves. Path to jar, modules. We're going to need the offsets, right? The bases. We're going to need a start value. We're going to need ending Y. Do we need to specify who gets the results. Because somebody wants the answers. Yeah, the main person who started it wants the answers.
They all, so everybody sends that for the last one at the same time, or they can send it any time, right?
Right. And then that final peer will be accumulating the answers or whatever. I mean, they'll do it the same way everybody else does, right? If they get two blocks, they'll combine them, and then they'll have a bigger block. But I mean, do we want to just use that mechanism to say? Here's the thing, though, because the main peer actually does have one thing unique about them, is that they never send blocks out. Right? They never send output blocks out because they'll just get it back, right? I mean, but if they never send a block out, they almost automatically get the answer because everybody will eventually send to them, right? They'll all be consolidating stuff, and then they'll be like, "Well, does anybody have something that's above this index or below this index?" And that guy will always be able to say yes, and then they'll eventually have the final answer. So, in a generic way, we could just say, if you never send a result unit out, you're the boss. You're the one who's eventually going to get it all. Right now, but that also brings in the cases of how do you know when you're done? So do you have to track the initial start and end index? And how do we distinguish between that person and the other peers without adding too much to our code that's useless for most of the peers, but only one person really... I mean, we could have the person loading the app, like the first person loading the app, like the king, right? The king peer. I mean, we can easily within paste make sure that they never emit that result unit, right? Just put a boundary between. Just say don't ever emit this signal. But we need to think about that as well. So, I mean, the peer names are going to be pretty. They're going to be solid, right? The peer names are like even when Juxta generates one. I mean, it's going to be the same every time you run based on your little configuration directory. So your peer name is going to be set. So we could just put in a peer name in the XML file as to who the boss is. It's just really a question of do we need that? And which objects will need to access that information. It'll probably be the result, the consolidator, right? The consolidator will probably need to see that and say, yeah, like if no one else wants it, give it to this guy. No, we can't do that because the consolidator, like the main guy, the first peer, right? They won't be able to accept result units that aren't adjacent. Yeah.
So it's to do either side, what you got.
Right. But if it's not adjacent, it won't do anything with it. It'll just hold it, and we don't actually have the capacity to hold it. Right. So right now, what if you receive a result unit that's not contiguous? Yeah. Yeah. So what we need to either do is...
And then what happens then? They test it. So
yeah, we actually
gets
need to omit it or something, but we can't just omit it because we'll just catch it again. So we actually need to make sure it goes off-site. But see, we don't want to do that if we're patient zero because if anybody... Well, actually, if everything's working how it's supposed to, you should never send it to somebody who doesn't want it. But we do need to make sure that if you do get something that you don't want, that maybe you're responsible now for finding out who wants it, or... But right now that'll take away from your work because we're only doing a single thread for the actual work. For the actual application, there's only one thread handling that. In other words, while you're processing finding that dude, right, unless we start breaking into thread pools or something like that, or have fire and forget types of messages we can do. Which, I mean, we can do. It's just... See, the thing is we can't just spawn threads for every object. Because what will end up happening is, right now, the single-threadedness is what's mediating the speed of our application. If you spawn like a new thread for every worker that needed to do work or whatever, what would end up happening is you'd be computing the entire input factory's range simultaneously. Which obviously for adding numbers and adding 10 sets of numbers isn't a big deal, but if these are of any significant size, that's huge. Because what will end up happening is the input factory will emit something, spawn a thread for a worker to handle it or whatever, but the main thread will be going already. So our signaling is mediating it. Actually, it starts getting bad when we get to this place where two things can handle the signal. That's on the other end. When worker sends the result unit, the consolidator will actually start running, and then also the work unit will start running. I mean, the input factory will start running. So you'll start getting multiplication there as far as what's running. And it's probably not that bad, but we do need a way to handle this. Peer zero. We need to handle peer zero. And we need to do it in a way that we're not doing a bunch of additional work on the peers that doesn't need to be there. So,
Peer zero be able to accept its consolidator, be able to accept.
like a bigger consolidator,
They can accept anything.
it's possible,
And you can
but it would have to have a different jar and configuration.
Can it be like have a special consolidator?
I mean, we can, and it's actually not that hard because in the module list, we can just have two different module lists: the one that the peer zero runs and the one that the rest runs. But I'd like a better solution.
Wait, so it gets the last one. So,
I mean, the other thing is we could make consolidator. Maybe we make consolidator accept things that are not contiguous. I mean, it'll consolidate ones that are.
Should we just make them all act like peer zero?
That's what I'm saying, is have them all act like peer zero, and as long as peer zero has some of the data and it doesn't let it out, it should eventually get everything. Somebody will be missing something, and that's what peer zero is working on. Even if it's just one number, right? Right? Even if it's just one of the y's, that y will be missing from somebody.
it can't be one, can it? You have a threshold where it won't send.
Yeah, but even if we broke that threshold and made it one, and everybody else is working on the threshold, they'd eventually get to the point where it's just like, I need this one person above me. And then they'd have to send it. And then, so, the other thing is how do we know we're done? Because right now we're forgetting the original, right? So,
We can
I mean, we can.
have consolidator. Since it's, you can make that part of the consolidator.
Mm.
So start in range and
It never loses the start and end range.
then since it's consolidated.
That might be nice. In other words, even on peer zero, input factory loses its start and end. It actually does deal them out. But by the fact that it's the only one with the consolidator from the start to finish, that's the good way to do it. That's the way we were looking for. Is consolidator should always remember the max that it ever saw. And that will actually handle the breakdown of we're actually a splitting tree, is what happens with our stuff when we split, right? This should end up being the path that the data takes back to us. Right? Now we may want to find mechanisms to not do this path, because this path might not be the best path. Right? Because if these guys are like low bandwidth or whatever, they might be the worst ones to Right. Right. Well, we're gonna have to handle the general case of going offline. or somebody takes over what they got. But yeah, we're going to need some mechanism for that. But this will handle how the data will end up flowing back this way, because that consolidator will have a bigger range than what it's working on. So it'll be a vacuum that will pull in the result units of the other peers. Right? Because those other peers are actually working on a subset, and then they'll get done and they'll be like, I don't have anything left. I got to find somebody with something adjacent, and that will be the peer above them. Right? So,
Would it be their sibling or the peer above?
it'll be the peer above. It may be their sibling, but it'll eventually be the peer above them, right? Because there'll be something it won't be able to handle. It'll be their sibling or their peer above them, but once they get their siblings, that one sibling who has both siblings will have to go to the peer above them. Because see, this tree is actually misleading. The tree actually looks like this. Because me and another grad student in the lab in my office were talking about this. You're half splitting. You're splitting and then giving half out. So it's actually like this. You actually keep a half, right? You have your block, right? And then you give the other block out this way, right? Which will then, which that block, you always have half. No, actually, you can split again, can't you? Half to the way.
When zero splits, then it would go horizontally with one. It's half and then zero splits again.
It'll go the other way, and this is actually quarters. Because I was trying to think how big this will scale, like how many peers that a single peer would have to track. And I think it's log n. But that's only statistically, because you could be the main peer that everybody keeps asking, but everybody would keep getting smaller and smaller, and there'd be one peer out there. There'd have to be one peer that has the biggest block. That's what?
The peer that splits the least.
Right, but so we'd have to statistically not be the peer that splits the least, but you are always splitting. Okay. So we're at half, right?
Mm-hmm.
We split again, this guy will be at quarter. Quarter. These numbers out. So we have nodes. And this guy is. So right now, yeah, we'd still flow up if we maintained the original range, right? See, the thing we don't have to worry about is that peer zero touches everything. We'll be touching all the blocks. There's no problem with that, right? Because no matter what block it has, it gave. If we always keep one of them. All the peers do that, right? All the peers are keeping at least what they're working on. But they have the possibility of giving it away. If we just prevent that possibility of giving it away, peer zero will always have a piece.
Wasn't that the threshold?
Yeah, they can't get it.
No. Even if you are past the threshold, if you don't have any, you eventually need to just get rid of that word, right? In other words, you're eventually going to give it up to somebody, but if you don't ever give it up, you'll never be working on anything that's smaller than the threshold. Okay? But that means that you'll generate work that's greater than the threshold. I mean, you'll generate results that are greater than the threshold. And that body of work, that body of result, you have the option of giving it away. If somebody asks for it, you can give it. Now, if you just prevent that option of if somebody asks you for it, you don't give it, you'll end up with all the answers. Right? So, right now we split like that. Let's say we keep splitting. We split this one again. Right, and now we're down to eighths. If this guy gets done, no, actually, there's no 2 here. Right? Just be like that. Right? Split one more time. Right? Okay? if this guy gets done, you have to imagine whether it's top or bottom half that it got. Let's say it got the bottom half, the half that's closest to this. Okay? If this guy gets done, he could send it to him if he's done with his 16th, right? His top half. Or he could send it to him, right? If his bottom half is done. But either way, they're going to flow up here, right? Now, well, this guy, if he's the bottom half of that, right? He could end up sending to him. Yeah, he could end up sending to him. So we could end up consolidating everything on one pier outside, pier 0, and then eventually go back up, which may or may not be good. He could. Because if he's the tail end of all of this, in other words, if he's the tail end of the quarter that was out here, and he's the top end of the quarter, then he's adjacent to that.
We should have two options. It's the person closest to the right and the person.
But do we have the concept of above us? Well, we do because we're watching. What I'm saying is if you just got a block. I mean, we'll have a concept of above us with the fact that the pier above us knows the original range. But,
So that's where we're going to
yeah. I mean, if we do it like that, who wants this? But should a sibling get it? In other words, do you want only because you have a larger range? If that's true, do you want the result unit only because you have a larger original range? If that's true, we will flow up the tree. So maybe we should do that. In other words, a sibling, just because you're adjacent, doesn't want it. You don't want it because you have a block that touches it. You want it because you have a block contained in your original range, which will make everybody act like pier 0, and pier 0 is the only one with the original range. It'll end up getting everything, and it works generically. That's what we want to do. The only thing we want to do, we don't even have to worry about not sending out a result unit. The only reason you'd accept an event from outside your application is if the result unit is contained within the original block that you understand. There. That's what we'll do. That's what we need to do. That will ensure that everything goes down the tree, that it all flows up from the tree. That does not handle how it splits. Because how we split is stochastic. It's still random. Right? So we just need to make sure that our randomness of picking piers and stuff works so that we don't, because we could end up just breaking down one side of the tree and that guy still has half. Right? If we never pick him, is one of the things. So we might even want to mess with the randomness by just having some sort of who has a really large block. Right? If you ask the network, hey, who wants to split? And more than one person sends back a message, you pick the largest one. Okay. So the idea is this: if what we want to do is we want to, for now, we just want to keep track, at least of the network side. I think we do want to track the peers that we delegated to. And because right now I don't think that's going to be a lot, because it'll be log n if we split in a good way. In other words, if we split randomly enough that it's uniform, then we should have log n peers. What I mean is, should we maintain at each node the branches of this tree? Know who they sent to, because that's actually the first person that you'd want to go to for waiting for, actually you'd be expecting work from them. So I guess pointing upward.
Yeah, you don't, but why would you need to know?
Yeah, you wouldn't.
who gave?
You want to point upward then.
So people who, the peer should know their parent.
Yeah, their parent, because that is the first person you want to send to. So first thing is, we do need to change the result unit. I mean, not the result unit, the consolidator. The consolidator should essentially just set up, they know how big it's going to get. Right? They know it's going to get to the point of being everything from the original input factory. And then what they can do is just fill in the gaps. Right? So Like for example, you're creating an array of start to finish z's, right? And then you have a start to finish y up there. So every time you get one, you can actually do bucket sort, right? You can just every time you get something, stick it in the array where it's supposed to go, and then when it's full, done. Yeah, and then you can say, well, you have to find somebody to give it to, and the first person you go to is above you. Yeah. So I think we do also need the concept of hints, right? Like the idea of like, if you're going to send this to a peer, I'll give you a hint that your parent is the best one. Okay, eventually it'll be the point that your parent isn't the only one, because if your parent goes offline, something else might have to happen. So you might have a parent. You might have to go to your grandparent, right? Or that's the only place you could go until you get to peer zero. So we don't need anything else besides these, right?
I guess if they broke, you could ask, who makes this range.
But see, the only person will be somebody above.
And then but you could set out, because you wouldn't know it. You only know your parent. You gotta look for your parent. They're not there. Then
You can ask, and then that'll find somebody. Yeah. All right. So we need to handle these. We can handle these already. We need to handle these. They need to be generic, right? Offsets is an array. How many different data types do we want to handle in this XML file? And then also, how do we handle getting these to the object? Okay, so you put offsets, you put bases, you put a starting y and an ending y in your parameters, right? In your what do they do for stars, right? For bullets? Star.
And just out of, when we're sending, I guess we kind of need some way to know whether we're sending an object or we're sending a file.
Right. I mean, the idea is, I think we're going to mostly be See, that's the other thing is, I don't know if we want to ever go to actually being a file. I think we need to just deal with objects and the serialization of objects, and that's the only thing we deal with.
But, alright, if they want to originally, when they orient to get the original job, you can send that as an object, or I guess you can load it and send it.
Oh, I see what you're saying. Yeah, let's have two mechanisms. Yeah, we need file and object. And file should just be handled by serialization, and then there's also cases where we're going to have data files. So we need two different
and then we're going
types.
And we also need to send messages too, just something else, not an object.
Yeah, so
actually,
send messages as events. Yeah.
Okay.
Right, because they can just be, we can just create like an event system. Because that's the thing is, all of this peer-to-peer is going to run like how we're running on our standalone machines. The only difference is that you go peer-to-peer by letting objects cross the boundary of events, cross the boundary of your local machine. Right? If you want to consolidate, then all you need to do is have an event leave that area and go to the networking subsystem. Okay? So a result unit, for example, once you fill up all your buckets, right, in the consolidator, once you fill up all your buckets, you should emit a different signal, not a you know how normally you send out like this result unit, like a. Well, actually, we don't do that anymore. We don't emit any extra result units because we're holding them all. Okay, so what we do is once the buckets are filled, we emit a new signal, and that new signal is result unit done or whatever. Done might be a good signal, right? That done signal isn't handled by any of our objects, right? We need that to pass out of our objects into pace. Pace will say, I got this done. If I'm patient 0, right, if I'm peer 0, done means I can spit out the results. Ah, that's how we do it. Peer 0 can handle done. No, it should handle it locally. Everybody shouldn't be able to handle done. it should be able to go out,
Okay.
right? I guess should have a local handler of done, is what I'm saying. That's is it never sends done out. That's pure zero. Do you see what I'm saying? Because normally your done going out means done going out is something that's received by another consolidator somewhere. Right? Because your done has this result unit attached to it. Right? So your done going out, you see what I'm saying? That done goes out and ends up being a consolidate message on the other peers. Or no, a work message on the other peers. Right? Because the work signal has a result unit attached to it. If you get a work signal with a result unit attached to it, you'll put it to your consolidator. Okay? So, this 16th gets done. It sends a done signal. The done signal has nowhere to go inside. So, we either need to...
Does everybody know the original peer? Did we say?
That's the thing, they don't have to now.
Okay, they don't have to.
Because what they'll do is, this guy will say, I have a done signal. I need that to get out on the network. And it'll show up on the network as a work signal. Somehow. Right? So the only difference between... So if it ends up as a work signal, let's say you're this guy and you get the work signal. Well, it'll go into your consolidator and you can... Right? Your consolidator knows how to accept that signal. Right? And then... You'll eventually get to here, and that guy will get it done. The only difference is he doesn't turn that done into a work signal to put on the network.
I was thinking if they say I'm done and I'm the original peer, then hey, I don't have to. Then I do it. Else, I send it up or I send it out. Otherwise, if I'm the original peer, then I just stop.
Yeah, I put it into a file or whatever. So
that way it will all be there. Because in that way, does peer 1 or peer 0 have to be different than everybody else?
see, and that's the thing is that is their difference. The good thing is that none of our consolidator and stuff is different.
But if they keep track
But there
of
is
who
one thing that's different, and that is this transformation of done into a work signal.
What if they know they're not the original peer and they're done? Then they would send it up, and you don't have to. There would be no difference between peer 0
Send it up where?
or when they're done. Don't they send it to the parent? Is that how it works?
Well, there's no parent.
There's no parent. Why?
No, I'm peer 0.
Oh no, I'm saying if they are peer 0, if they everybody can check. I'm not peer 0. I send it to my parent. If you know.
Right. If I don't have a parent, I am peer 0. There's nowhere to send it, but it needs to go somewhere to some object that can write it, or like. So I mean, what I'm saying is by the fact that you have the presence of an object that can handle done, or not, is what is kind of your trigger. Because if you have, in other words, if you put an object in there, that would make it so that we have a jar, a parameter sweep jar, but then we have this other jar that is done jar, right? Like this jar that can handle the done event, which is take a result unit object and write it to a file, write it to a screen, print a pretty graph, whatever. So then they could have one extra thing that the others don't. But then we need some mechanism that if you can't handle done, what does it turn into, or how does it? No, but see, the thing is we can't just send it out as done, because that would mean all the other peers have a handler for done. You see what I'm saying? You don't want it to be a done signal. You want it to be a work signal. If you don't have a local. Oh, I mean, we can handle it in consolidator, I think. If you got nowhere to send it, but that would imply that all the application object knows about all the peers and the parents and all that stuff. I don't know. For right now, we'll get the result units in, and they're going to emit a signal.
So the done John. That would be our another module that would, when we are finished with all our work, that's what handles it and does whatever we need to do with it, right, or whatever. Could we have it some way where our application, or maybe like have a flag that, I don't know, when you run your application, be like, I'm gonna be like, if you know that you're gonna be the
Yeah, I'm gonna be the
zero
done
peer,
guy.
Then
But see,
then
the
you
thing is,
instantiate it. Otherwise, your other peers aren't gonna have. They're gonna know that they're just gonna be a regular peer, that they don't have that flag on, and then they don't have an instantiated non.
yeah, I mean, peer zero is gonna have a knowledge that it wants the done object there.
You could do that. You could put a path into the jar and just have that be. Just don't send it.
Right, you'd have to have a different XML file then. See, the thing is we don't want to send the done object to everybody, right? That's overhead that they don't need. That object isn't. So we really, I think what we need is just another XML file, like an auxiliary XML file that peer zero has. And by having that and wiring that in, see, that's why I want something that. Normally, what ends up happening in the handler is you have your. This is your pace event queue, right? That's your pace event queue. You have app over here. You have net over here. You have interface, right? Okay. Normally, all the signaling that happens in app, if you can handle the signal, you don't give it to any other queue. In other words, most of the signaling happens internally. The neat thing about a done type of event is all you have to do is not have one of the objects in here handle done. And what will end up happening is this queue will send done to the queue above it. And this queue will look for something that can handle it. You see what I'm saying? It'll query its sub-queues as to who can handle done. So for peer zero, all you need is another little app queue here that handles done. And this would be a separate jar written in the same way that just has this master consolidator that can create a report or whatever. Which is slick. I mean, that's a slick way of handling it. So the thing is making the other peers, the peers that are just regular guys on the network or whatever, making them not having that creates a vacuum for this done signal, right? We need something to do with it. So we need some mapping of done. You see what I'm saying? So done needs to turn into something else, like work. And if it's work, we need to make sure it gets to the, like a work out, like a get out of here work signal, right? Like a work signal, like a remote work signal. Because what that will mean is we don't want to make it just regular work, right? At least not at this point. Because if it's regular work, where will it go? It'll go in here, because those can handle work signals. And then it will get it, the result unit will be, it doesn't need it anymore, so it'll actually spit it back out. Right? Oh, no. Because this will be done. So all that stuff will go away. So there is nothing to handle work anymore. Maybe. I don't know. But the easy thing right now is, if you get it done and there's nothing to handle done, turn it into a remote work signal. And if you get a remote work signal, turn it into a work signal and put it in the app. See, the thing I want to stay away from is, if I'm this peer, then do that. If I'm that peer, then do this. I want everything to really signal in a way that's... So, like, for example, one way to handle this might be on peer 0, it's the one with the final consolidator, like the final reporting done. But everybody else might have a different done that is turn this done into a remote work signal. I don't know. Call what?
Yeah, just use it as a signal for when last that will actually trigger go down.
Go to, yeah, go to print. Wait, which master? The
The Q.
yeah. It's gonna be different in the sense that he has an extra module. But
I mean, it's all.
no, see, that's what I don't want. I want the consolidator class to be the same because it does have to do a consolidating job. It has to do the same one that the others are. It just has a bigger one, right? It just has the biggest. It has the biggest range of all the peers, but it still needs to do that job. And then the only difference is that when it's done, normally you omit that result so somebody else can get it. In this case, we just want it to go down to the master queue, and instead of going out to the net, go this way. But
Wait, so why wouldn't that work? Just having another queue that only accepted that done signal. And
Well,
everything else. How
because
would other
if
people
you
do
can't
it?
accept the done signal, it needs to do something else. It needs to turn into a work signal that's received by another peer.
So let's just make be aware that it's not master. The master knows it's supposed to take.
Just tell it in relate. What's my username and password again?
Richard and Richard P2P.
So yeah, done.
Huh?
So
So I mean, no,
Wait,
okay.
who
So
would-
take a different path, but where do you put that different path? In pace?
Brennan, so wherever.
like I thought.
Yeah, but wherever you want,
Oh,
wherever that network signal is generated.
oh, okay.
We don't have a place where the network signal's generated yet. That's what I'm saying. Right now, done gets into the master event queue, right? It needs to leave.
Pace knows to send it to the other.
If it sends it to the other queue, you're the consolidator, right? I mean, you're peer zero. But if you have a different one there,
Why can't?
So, if you were, would it work if the master node or node 0, when it instantiated its modules, it would have that finisher, whatever module, and that's what is associated with that done signal. Otherwise, it's associated with the net module, and that's what catches it, passes it.
yeah, but see, we can't pass it to the net module. Not done. Because that's application specific, right? See, so I mean, what I'm thinking is we have, yeah, I mean, we could have a different done handler on the peers, and that done handler on the peers is one that flips the message from done to
So just have a
remote
modified.
work or something.
So everybody would admit done once they're done with their work, but you're saying some. if
Some
you're
would
not
flip it into
to
a
result
result that goes to somebody else,
and then the
and one different
original
one
pair
would
resend-
write into a file or whatever. Finisher, like the finisher. So I mean, we could do that. We could have a network aware object. I don't know. We need something at the end. I don't like this. I don't like what we have here.
What's wrong with the original one?
Because we need a way to answer this. If I'm peer zero, I do this. Otherwise, I do that. That we're not writing directly into pace. I mean, it'd be better if we were doing it through some sort of signal handling or something like that. Yes, there is awareness that you're patient zero. I mean, you're peer zero, right? There is awareness of that. But how do we express that? How do we make it so it's not in all of the perimeter sweep app? So that we're giving all these other peers some extraneous stuff, you know, like writing it to a file or whatever. Like for example, if you don't do the writing to, if you don't send the writing file out, nobody does any file I/O, right? Nobody even loads that stuff as far as like, you know, like imports it or anything because they don't actually have to have awareness of any file systems. You see what I'm saying? They don't even import the classes. Because if you have it in a separate object that you're not sending out in the jar and it's not being instantiated by all the peers where they sit there and go, am I peer 0 or am I not? And that kind of thing. I don't know, but I mean, if you want to do it with a flag, where do we code the flag? I guess.
Could you?
Well, could the I don't know.
Because I mean, we can do that. Like in Consolidator, you can just have if peer 0 write to file when done, otherwise emit done, or otherwise emit work. Huh?
I used to think of things I'm not thinking of.
All right. Well, I mean, that's what we need to come up with. Is that, and we also need this idea of
We do it handle it by orientation. Like if a peer is ever oriented, then they get this kind of modified XML so that their finisher module is different from the original the node 0 because he's never going to be oriented since he's the creator.
right. Yeah, something along those lines is like, yeah, maybe it is in the orientation. Like as far as if you never orient it, in other words, if you're self-orienting,
Then you use
you can do all kinds of other
basics.
additional things. Like even if it's just and that's what I like about this idea of having an extra module that can handle done. Right? Here's the thing: is on the original peer. Okay. What I like about this idea is that you can load the jar, load the XML. All of that runs the same on every single peer, no matter what. Right? By just loading an additional jar file, which has a done handler in it, by using the mechanisms within PACE, you can now handle the final signal, and that will kind of take care of this idea of never sending done out.
Because we could just have them all be going out to the network, except for the self-orient peer, which says it's going on the network, no wait. Send to load new document.
Right. But we do we create do we create additional objects? I mean, like during
Well, 'cause
orientation, do we?
It would be that base jar that everyone would get the same jar, but the XML would just be different because their finisher module would be initialized differently to handle that signal differently. We would do that like that. That way, since the master node never orients, it has that kind of like fully functional finisher node.
Right. But what do I do with the consolidator objects that are emitting their final result units? What signal should that be? Should it be done? Okay. Now done needs to be handled in some way, right?
It's going to go to phase 2, which is going to send it out to the network.
Okay. So on that peer, why is it sending it to the network, and on this peer, why is it not?
Because that peer actually has some of it oriented. Yep. Someone has a bigger.
Because we have a what's okay. Yeah, that's what you guys are saying. Is we actually put finisher in here, but we don't put it in the jar. And we pass, yeah, like you're saying, we pass a different XML over the network than we do on disk.
So they get kind of like a
So we need a private section, like a private section of the XML file. Because here's what I'm thinking: is you have a private section of the XML file that when you're loading the XML file, that's what you load that stuff. But on the stuff outside of private, Pace actually generates another XML file out of that information, and that's what will go out during orientation. So the only difference will be the XML files that we get, and it automatically creates a separate one for Peer 0 because it's the only one that's loading from file. All right, I like that. It's not my mouse. That's my mouse. All right, so let's edit this. Okay, so we need a private section of some sort, right? And this private section will have a path, and it'll have modules. It'll basically have everything that we have there, right? Just have another set of these. The difference is that, actually no, we just need one thing in there. Path to jar, modules, and then it could have parameters, right? But in this case, there is no parameter, right? It's just by virtue of handling the done signal. So do you see what you see in here? You'd have a path to a different jar, and the module would be finisher. Okay? Just by doing that, this application object will see a different XML file, right? The one from file. It'll load it, and the reason I like this solution is that finisher comes into the scope of the app object. So that handles it not emitting done. Because if a done signal comes out, there's an internal signal that can handle it. And then everything else will go out to the main event queue. All we need is a generic mechanism that makes a signal either local or foreign. Because if it's a foreign done, we do want it to come into the app to see if we can orient with it. I mean, to see if we can handle it. We need a special kind of event, and that's an event that can go from one signal name to another. What I mean by that is this. If you have a generic mechanism that's say like done.remote, okay? All you do is you have a handler inside app that can handle done.remote. So consolidator in here, the consolidator, right, can handle done.remote using what? Using consolidator, right? Right? But it can't handle done. Here's why I'm really emphasizing this idea that the signal needs to change. Okay? Because the usual event routing mechanism is app says, can I handle this signal internally? If I can, I handle it internally. If I don't, I pass it to the parent queue. Right? So if I have done internally and I'm Peer 0, I have an application object that can handle it, so I handle it internally. Perfect. Right? But if I can't, what do? I pass it to the parent, which is fine. Pass it to the parent. Pace will see, I don't know how to handle this, so stuff I don't know I'll send out to the network. Right? So I go and send it out to the network. Nobody else on the network will be able to handle that. Why? That's the only reason it got out, right? Is because I couldn't handle it, so why would anybody else be able to handle it? So there needs to be some sort of transformation that kind of says, oh, done becomes done remote, gets emitted, somebody else can pick it up, and then it can flow back in. In other words, I can't handle done remote, I can only handle done. Let me put it down here. Oh, I can't handle done remote. I pull it in and I consolidate it. Yeah? Yeah. 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 Okay. So we need a private section in the parameters. The rest will be the same. The only difference will be the presence of an additional module. Modules will be just finisher, and it handles has slot for done signal. Okay, now how do we handle these transformations? Do we need a group of objects that get loaded into the network side for our applications? Do the applications have to be pace aware? Do they know about who oriented them? Do they know about that kind of stuff? The key is this. I don't want to make this event routing and everything just work for our app. There are apps where you don't send to your parent. There are apps where you send to your sibling. There are apps where you send to a random host. There are apps where you do other things. Right? I don't really mind so much the idea of orienting off, like, say, a random peer, but because that, I think, works for all apps. This idea of spreading load around, right? But we need some way of deciding that we want to transform this done signal into a remote done signal. How do we route that, right? Because we can't send the done signal to anyone, right? Who do we have to send the done signal to? Yeah, someone who wants it, and that's going to be someone in our lineage. But that's really just for this app. We could just ask who wants it. It would also be slow because you have to broadcast. I mean, do we? Oh, because if we don't broadcast, then we have to track. And if we track, do we do that on an application-specific basis, or is there a generic tracking mechanism, or can we route signals to specific peers? Do we want to write that into our app? For now, let's do this. We'll ask. Who wants this? Consolidator will give the answer. Ooh. Wait. And Consolidator will say what they want the event to be, what signal they want. Here's what I mean. This just handled the transformation too.
So kind of gates.
All right. Signals we can't handle goes into the network, right? The network asks, who wants done? Okay? An event will happen on all the peers that is not done. It's a who wants event, right? Because this was generated off the network. Who wants signal done is the event. Consolidator, right, has a slot for who wants, right? Who wants done. It has a who wants. The data type is signal. No, string. Who wants string done? Yeah, because we're gonna have other signals like who wants orient, who wants. See, but who wants string done? No. It needs to be the object though. It needs to be the whole signal. Oh, we don't want it to be the whole signal. We don't want it to be the whole signal because it's big. We don't want the whole thing to go out. Oh. Huh?
Well, that's going to leave a lot of signals.
because we don't want to send out the entire result unit as a broadcast.
Let's
So
see.
could you do that?
But we need to be able to send start and finish at least,
Well, actually,
right? Because we need to say who wants this start and finish, start and end. Because if we can send them those two numbers, they can decide whether they want it or not. We do have to ask the question. We have to ask the question. But I think a signal, I think an event needs a method that can generate its query. Does that make sense? That can generate its question to the network. In other words, if this event is remotable, it needs to have a way of generating the question. Who wants this signal? But, all right, let's leave that. So who wants a signal, right? And it'll end up being a signal that is a done query, start, end, right? Okay. It's going to say, I want done query, right? So it's going to emit, I want, right? It's going to emit, I want, with a string, and the string will be work. Why is the string work? Because that's the signal that it wants to receive, right? So it will say, network, get me this event that wasn't handled by anybody, and create an object that is signal, same data type as the event you had before, that is work, with the same data. And then what will happen? Can this guy handle work? No. Send it here. Can this guy handle work? No. Find who can. This guy can't handle work. It'll pass that into result unit. Who wants and I want? We need those signals, and that's pace signals. Those are pace signals, not. Who wants? I want. Work. The work signal is not remotable. We need remotable signals. Done is remotable. We need remotable signals. Work coming in is not remotable, so it's not handled. Yeah. Okay, so what I'm saying is, because see what I'm trying to think of is these signals. If we have work let's say the work signal is not remotable, the done signal is remotable. Okay? The question that that net is asked is, can you handle this? Well, we don't want it to say, yes, I can handle done or I can handle work, because it shouldn't have to know about those, right? Net should be able to handle anything remotable. So you should be able to ask net. You shouldn't even have to ask net. You should say, oh, it's remotable, I'll send it to net. Right? So if it's remotable, I give it to net. When it transforms, what it'll do is it'll remote that signal to another net, right? Another network subsystem. That network subsystem will instantiate an event, and it will call it work, and it will have so and so, and it'll have that, and then it'll have the data type and then the actual object. But work is not remotable. How does it know it's not remotable? It'll always create an object that's not remotable, and it'll send it down. I don't know. We have to see how we're going to do that. Or anything that it receives from something else, it'll always emit to the main queue. And we don't have to worry about remotable, not remotable. All right. We'll have to think on that. Anything net gets off the network, it'll put into the main event queue. Anything not handled by anything will attempt to be handled by net. I'm trying to keep the tags work, done, all that stuff out of net. In other words, have no awareness of it, but not create a loop. If you just say handle any event, you end up looping because it can't get out. But if you put it here, if this guy can handle it, it'll keep it, and otherwise it'll send it on. It also gives us hopping. I don't know. We'll see. Okay. So I don't think we need to tag things as remotable, not remotable. I think them getting into the queue should be enough. Not handled by anything. If nothing else handles it, net handles it, and and it emits a who wants. I want comes back. I want comes back. You remote it. Instantiate it as what they said. Put it on the main event queue. We're in business. And we're in business.
We rule.
Nick, do this.
Yes.
Do this stuff. I also need you to, in your parsing of this and working with this, you need to generate a public XML file.
Okay.
It does not have to be. Does it have to be a file? Does it have to be a file? Does it have to be a file?
Is there an XML object?
Is this the orient message?
Yeah.
Start and end will be, that's the orient message. You don't have to generate a public file. You need to be able to generate this from.
So this is okay.
This is the orient message.
Now.
This is the orient message. This is the orient message. Yeah, see, I didn't want it to be a file once it got on the net, but it needs to be something that's parsed and has the same data, right? But this is the orient message. This first XML file is the orient message, which is pretty cool. That's the orient message. All right. Where does it need to come from? Who gets asked about orientation? The input factory, right?
Well, they asked to.
Yeah, they say, hey, I need an input factory to orient on.
So input factory.
We ask input factory, say, hey, I need to orient. And they'll say, oh, here's start and a finish.
And it's
I'm giving that to you, and I'm going to not use it anymore.
So orient is a slot on input factory,
Yes.
and the network would send that to somebody,
Yes.
to a random person.
No.
Signal.
We'll send it to the person who asked for orientation.
Okay. So somebody asks for orient.
Who can orient? Who wants orient? Who wants
Just
orient?
grab some random person.
And then
How
that
about-
person will answer, I want.
How about you say you orient? Why ask them? Send an extra message. Can you get the first person that you can find
Yeah.
to orient? 'Cause then
No, it has to be a question because if they are at their threshold or they don't have any work or something
Oh,
like that,
okay.
then they won't be able to.
Well, then they can send another signal back to you saying,
Oh, yeah, I don't want. In other words, I can't.
yeah.
What's that? Oh, and then somebody. Oh, but then we have to. When do we break off our set? That we're not working on it. Huh? No, what I'm saying is this: is if it says I want to orient, and everybody just who can orient comes back. Oh, you mean they're saying I will, but then we still have to go through a dialogue of orienting. Because we can't just start orienting, right? Because if we start orienting, we'll be cutting off half our block, and chances are it won't get handled. What I'm saying is this: if you said, yeah, both sides, like the person asking to orient already implicitly agrees. So if he asks who wants,
And then
Because then he chooses the biggest one.
then he chooses. Oh, I see what you're saying. Right.
So everybody who's got a block cars back and all about, that guy's like you.
Okay.
And then that's the big one.
We have another signal that says just an orient signal.
And
Everybody who could potentially will say, who wants start end? You know what I'm saying? Like the same idea, who wants input factory start end? And then he'll answer one of them, saying, I want. Then they'll remote the signal and send it.
and just so I can remember, the orient you send the jar first, right? And then they load it.
Yeah,
That happens in orient.
the jar happens in orient. I wonder if the XML comes first and the jar comes next.
Yeah, I think so.
XML comes first, so we need to run into the event of not having the jar. If we don't have the jar, we can find the jar. First person will ask is the orienter.
You can ask anybody for a jar.
Yeah, but first person will ask is the orienter.
Well, yeah, if he's still out there.
Because we know he's there and we know that he has helped us.
And then each peer, do they hold that file in memory or do they save
The
it?
XML,
No, the jar file.
it'll be a file.
And then you save it to disk or just keep it
It'll be saved to disk. The jar will.
in memory? Oh yeah, I guess you have to
The XML will be maintained by state. It's an object. It's a configuration object. We need to create a configuration object that we can pass around on the network.
So
We need a generic object passer and a file passer. That's what we need. We need two things. We need a marshaled object sender receiver, and we need a file sender receiver. We need a configuration object.
But the actual XML can just be sent to orient. It can be an object too.
Yeah. So we'll never see it as XML. Well, it'll just be the configuration object. It'll be a configuration object. And the easiest thing, the thing that makes that easier is if we make a generic configuration object, Peer 0 will just load the XML file and generate that object. And then that object can be used to instantiate, what's it called?
And I guess we need
We can instantiate input factory and consolidator off that object.
and then everything else, the signals would be through
So
messages.
is the
Yeah.
Plain string messages.
String messages. Or basically just string objects that they're, or event objects with strings in them that they
Yeah,
pass
okay,
as
so
the
that'll
generic.
be event objects that you're passing through the network.
Yeah.
we're gonna need a
In a knit? Like in a knit method?
like where it comes in to add the like orient, we're gonna need a pre-orient to get the
Yeah, they'll have to be yeah, there's like a how would you orient me message. Yeah, like a pre-orient. If you actually oriented me, how much would you give me? But we can do that with just regular signals. Right? Input factory could just get regular signals that say, Yeah. how much would you give me? And then when a message comes that says I want, that's bound to split. Because you're not necessarily going to give them what you told them. You're giving them the split that you have now. Because if they took too long to get back to you after asking for orientation and you have already oriented somebody else, you may be splitting something different. But the key is that they asked you, you said this is how much I'd give,
What if you split and now you're at your threshold and they send you a
then they won't get an object back and they'll have to orient again. So they'll either need to time out or, oh, we can just give a no, I'm not going to orient you message. And they can move on. So who's orienting? Another input factor is orienting. Because it's empty. Input factor is going to have to orient and be oriented. When you're empty, You send out your done and whatnot, right? But then you also send out a, hey, I'd like to orient. Hey, I'd like to orient. Somebody comes back. I give you this range. You say orient me, and you get another. In other words,
Absorbs kind of stuff.
absorb and split. So yeah, it's just tying up those two. The stuff emitted by split, absorbed.
Absorbed already
Yeah.
got the thought that.
To start
Yeah.
generating work again.
Like it consumes it, it's empty, and it does get
New work.
new work. It sends out a start to which is caught again by memory. So there's
Right.
that is right.
Yeah. Absorb. Empty. Input factory generates an orient message. What would be in the orient message? Nothing, right? I'd like to orient.
So the orient message object, it's created from that. It's going to only be able to be like half complete because it's not necessarily going to know what range it's going to give out right away until someone asks for some work.
No. The orient object is just a signal that whoever receives it needs to say how much they could potentially give. So the orient message is a broadcast, or it could be a limited broadcast, it could be a random broadcast, whatever, a random unicast. However we do it, we can decide. But we orient, right? I orient. Any input factory that gets that will say, here's my start, here's my end. I'd split it. Here's what I would give you. I'd give you start to 1/2 end, or whatever, right? I'd give you start to 1/2. So I send back another message that says, I would, give start and end. Okay? Start and half. That same person, that same thing that was empty, would say, I got that message and say, oh, okay, I want that. Right? Or it would get a bunch of them in, it would say, I want this one, it's the biggest. It would go back to that person and say, I want. And then that person would send out a signal which has the actual input factory. They would split their input factory, take off this other one, send it, the other person would get it, absorb, kick off a start signal, and start running. It never got an XML file, right? Or it never got the
Only the
configuration.
XML files they-
Oh, the configuration object is that.
The object and then it sends the file.
Configuration object.
Pretty much the Java where the object is an XML file.
Yeah, but the thing is, here's the trick: is it's got the path to the jar in there.
No, but we can just let the application handle that. It'd be relative to where the program is.
You might not have the file. Well, we want the getting of the file to be separate, right? Because you're going to be orienting many more times than getting the file. You're going to be orienting every time you're empty.
Joining the configuration object once too, right?
Joining an application will take care of the file, the jar. Yeah?
Joining an application.
There's a separate orient mechanism that goes on here.
Alright, so we're going to have our configuration orientation.
But shouldn't
and then
that be?
a jar
Don't you get the configuration at the same time as the jar? And
No. The thing is you're getting a configuration, these things right here, at many times other than application startup.
configuration doesn't that?
We're not going to send the XML file anymore.
Okay.
We're just sending like these.
But I thought you only sent the XML file. Once you got it, the modules that you load and everything, and then on the other orient, it's just I need work, so give me the work. So I thought we had two orients, one
wants
to
to
set
have all that
everything
data
up
with the
in
jar.
the jar with the load. Once you loaded it, then the other one just give me more work. Because it already knows where to have
Yeah, where all the modules are.
Yeah.
No, I mean, I guess
That's what anything else is.
the thing is this is not as exactly like the orient message as it kind of is. The first orient message is just getting the app. You get the app. Oh, is just getting the app. Because once you get the app, you can instantiate all the modules. The input factory will be empty. It'll request work.
When you do the second orient, all you really need is the all you're really getting is just
As an input factory.
the offsets basis.
What I'm saying is if that you load these modules with nothing in them, they'll generate their own message, which is give me work.
There's two orients. Or is orient one?
Because a group of messages that say, hey, orient me. If you load the modules empty, they should generate a work request or an orient request. I want to absorb. So our configuration object will have all the parameters. No, it'll just be an input factory. And an input factory, when you get it, has all the offset spaces, starting Y, starting, ending Y. So we need to make ourselves equal to that. We will have no offset, no base, no X, and no Y.
I didn't know they
So
had
it's
Yeah, well, that's the
Yeah,
radix
I knew.
calculation.
instead of your fudge,
We actually need,
it'll just be an emit.
yes. No, it'll be a nothing, and then when start is gotten, if you get a start and there's nothing to generate, it should emit need work. Right, there's nothing for it to do without offsets and bases. So the absorb, right now, does absorb also take the offsets and bases? Just the start X and Y, right? All right, so we need to absorb all of it.
And all right, another question I have is: does a network, does a network queue actually send files? Is it the object that's sending it, or would it be some like the object that has the input factory? Would that be sending the file? That would be
I think the net queue will actually send
net queue, and then so you just have who you want to send.
The only file we're going to transfer in all this is the jar.
Oh yes, objects too. Like a work
Right.
unit, if you want to send work.
Oh yeah, we definitely need to send the objects, and those will be done by encasing them in events.
Okay, which has a name of who it wants to go to.
Right, and then
So does the network queue look at the event that it's got?
we need a way of addressing.
Yeah.
All right,
How
let's.
does the
We need to
network
come
queue
up with
look?
what message types we need. We need, whether we need broadcast, directed, the idea of random. Do we put those in the events? Let's just send to individuals for now. Individuals and broadcasts. That's what we need now. Individuals and broadcasts. How we address them, we don't know yet. How do we address them? I don't know. So you're gonna do some of the stuff with the consolidator, right? We need net. We need net framework at this point. I'm gonna put in. I'm gonna put in the queue and the message routing. We're gonna send it. How are we gonna address? Who wants? I want. Who wants? I want.
Well, I guess the broadcast, they're kind of, then you kind of bypass the network queuing, or you could just, or you could send it through a network queue to this person, network queue sends it to that person.
Huh?
I don't know, I'm kind of sleepy. Alright, say you say, I want, you send out a broadcast, and then, so I guess then you're talking directly to each other.
Yeah, see, that's the
You
thing
have
is,
no
do we
need
want to
to-
like just handshake and then have a direct connection, or is it
probably work faster.
I want, you want, or I want, and then put it on the network and you pick it up by virtue of being the one?
I think
who's
it's
requesting.
kind of, if you go through a network queue, it kind of is working against the decentralized. Because you're not really, you have it as a queue to serve as.
What do you mean go through the network queue?
Oh, wait, does each one, how many network queues? Each one has a network queue.
Everybody has their own
Yeah,
queue.
network queue. This network queue sends
See, I mean, that's the thing is, okay, for now, here's what we're gonna do. All we're gonna do is broadcast right now, and we're gonna just have queues that just share network queues. In other words, everything that you see broadcast, you put in your queue and see if you can handle it. Yeah, 'cause that'll be kind of funny.
So if you, like,
Not pass it on.
Well, there's no need to pass anything on. What I'm saying is your signal goes on the wire and it's just there. You know what I'm saying? It's like right before you put it on there, we need to go through this who want I want thing.
do we need the network queue?
We definitely need a queue.
Because it's kind of like, you can have, let's say, you send out, you say, I need to orient. You can send out to everybody.
That's what I'm saying. Is you put that like by basically. When I say putting it in your queue, that means broadcast it so everyone else can get that event and put it in their queue. Okay. Now, what they do with that is handled internally on the individual clients. But yeah, so we need to design our event messages so that people can kind of say, "Oh, that's me. I can send them my work." In other words, you just put an event in the network queue. Like in other words, the global network. Anything that you put in the network queue right there will end up everybody having it in their queue, right? So I say this. I say, I want to orient. So everybody gets that message, I want to orient. All of them will route that to who? Their input factory. Their input factory will say, I can give this. They'll just put that on the broadcast queue. You're interested in that. You'll pick that up, right? And you'll process it with,
I want it.
we need another object that compares all the input factories and chooses one. Input factory might be a good candidate for that. I don't know. No. Because it needs to wait. It needs to say, I have this many, or I've waited this long, it's long enough, I'm going to go.
Needs to get good sense.
Was that?
Needs to get good.
Yeah, it needs to say, I'll wait up to 3 seconds and see all the different things that come in within 3 seconds. Because it has to be timeout based, right?
Mhm.
Everybody responds. Pick one of them, and they say, I want this one. Everybody gets that message. They look at it and they say, oh, that's the one this guy has. I'm not doing it. I don't have that. I'm not doing anything. But the guy who does have it will say, okay, I'm putting this on the line. So in the events, we need to put in like addresses and stuff. I want Nick's, or I want Richard's. And then so when you see that message in your queue, you'll say, oh, Okay. So we'll probably actually let's make one. We'll make one one parameter sweep object that's network oriented, and all it will do is handle those little things, even the input factory stuff and all that stuff. It'll talk to the input factory and know. It'll ask it, hey, what's your range? Type of stuff. Oh, about half that's this. Yeah, we'll have to wire it up together. So,
Probably have some more ideas.
yeah, once we start.
trying to write it.
But what we need to do is be able to have these event objects be global
I do
via
need to be able to
broadcast.
talk to some-
We'll eventually need to talk to individuals, but let's see.
Well, the way.
Let's
yeah,
talk first.
Like, basically, you just put something out to the group and say, "This is how you talk to me," and everybody.
No, I know there's not a problem of us being able to talk from one to another. The problem is this. How do I make it so that I can talk from one to another without having to code that all into my application?
Wait, is it input factory part of the application?
Yes.
Oh,
That has input factory, consolidator, all that stuff. All this needs to be generic. It has to be in a way that you can kind of ask the application, hey, what kind of stuff do you want? Oh, okay. Go over here and all.
yeah. Okay, yeah. So then you do need to.
Yeah. And I mean, we'll need network aware objects in our application, but I want that to be a good set of network aware objects because we don't want it integrated throughout the whole thing where, the worker even has to decide whether it should talk to a peer or not talk to a peer and stuff. I just want it to be signals moving around. Some of them know that there's a network out there, some of them don't, right? The fact that worker doesn't have to know anything about these orient objects and stuff like that and orient messages and everything, it can just chug along and do its thing. All that insulation is good because we can reuse a lot of code. We can do all this stuff, write a bunch of different applications, and none of it gets changed. So, for example, like this parameter sweep stuff, that can work for everything. All you do is just change worker, all good, and then like linear programming, all kinds of other different things are like parameter sweep. So the better we can isolate all that stuff as far as what actually goes to the network, the better. So we want to do it in terms of primitives, in terms of random hosts, broadcast, not broadcast. If we are going to do some stuff where we're talking to individuals, we need an object that can track those individuals. Like we might have like our network object track the parent, because that might be a good way to route that stuff. And the neat thing is that stuff like done, like we've been talking about done being emitted by the, by the consolidator at the end, and that just goes to the network. Well, we can wire stuff into that by grabbing the done with our network-oriented object and saying, oh, actually, let's try the parent first. You know what I'm saying? And then just emit a different signal that says, in other words, by grabbing done, we can say, let's find the parent and then try to send it to them first. So our programming becomes just this really nifty, just tying of signals to objects and letting the objects handle everything. So for now, though, the most basic form of communication is broadcast and everybody gets it. So let's just do that. And from there, once we can see objects being instantiated in the network queue, then we can get down to where do we want to track who talks to what and whatnot. And there should be a generic way of us getting at files, because this idea of just getting the jar and the modules, this part of the message, right? This part is a little different from this part, because this part we don't need, right? This part is going to be from the input factories that we absorb and split. This part, though, we do need. So really, when we were saying there's two different orients, there's not. There's an orient and then there's the request work. And the orient is the only concern with the jar and instantiating the modules on the host. And that we don't even need to be, we don't need to spread that around. Right? That it doesn't matter. Anybody can orient you in regards to that. So that's a one-time deal. It's just getting the file and the initial list of modules that you need to instantiate. I don't know if we're going to handle that in Pace or in. I think we handle that in Pace.
Yeah, actually, that's the generic one.
This is private too. Let's make this private too. Yeah. So this is the part that's public. Path to the application jar and the module list. Do we want the jar to just report what modules to instantiate? That might make all of this easier. That way it could just be a jar.
Yeah.
So what do we have? Just a generic object in there that says load these other objects? It's a vector, a manifest. I mean, no, you can't put like attributes in a manifest, can you? Yeah, let's do that.
Wait, what are we throwing in
Everything.
Sweet.
No, we're going to put the module list in the jar. In other words, a list of things that are things you should instantiate when you load this application. It's a kludge, but that's cool. We'll do that for now. And that way the orient message is strictly an input factory. There is no orient anymore except for the fact that you've loaded the jar. But see, you load the jar by joining the application group.
Yeah.
So the jar can be part of the
Well, if
application
you join-
advertisement, and that can be generic to all of Pace.
Well, if you join the group, somebody still has to send it to you.
Yeah, that's what I'm saying though, but that's a generic mechanism of Pace that's not in any kind of orientation or anything like that. That's even generic in Juxta, because Juxta has, when you join a peer group, you can have stuff in that XML that is the peer group advertisement. Well, by joining it, you're kind of saying, by joining an application group, you're saying, give me the jar. Give me the initial jar. So by joining the initial application group, you get the jar. Yay. Yeah, then you start it, ask it what modules I should instantiate. You instantiate those, and then all of a sudden you're talking to, you're sending out that message for I need work. Which is cool. That's good. I do not need file transfers yet. What I need is, not in the sense of a generic way of us sending events for file. I need when you join a group, you get the jar. That's where I need file transfers. I need file transfers in the sense that when I'm joining the group, I can do an actual hard-coded kind of juxta set of code that says, I join the group, and I join the group, I get some information from the group that says what the jar name is, and then I get the jar name. In other words, what I mean is that's hard-coded into Pace. We don't need to worry about that being good for all the applications because this is the starting point of the applications. Okay, where we start getting into, and then from Pace, if you ever join a group, you get a jar from it, you'll instantiate that jar and ask it what modules, and that's going to be the same every time. And then the only difference is that you load that jar and this XML file. All right, we don't need a private section anymore. We need two paths though.
That to the starter jar.
No, we don't need the path to the jar anymore either. We need an XML file that just has the parameters. We're back to where we started. No, because see the thing is no, the thing is this is because the application. No, we're back to before where we started. You know, when we originally started just having parameters in it, because by the act of loading the jar with the XML file on the peer 0, we don't need to point to the jar because we're going to get the modules from the jar, and we're giving it an XML file. We should give it the jar too. We give it the jar, the first XML. Ready. We give it the jar. We tell Pace what the jar is and the XML file. We'll do the same thing on every peer server. Right? Same thing with the jar. Load the modules. Load the XML file. The modules abstract module needs two different constructors. It needs 0 zero argument constructors and configuration object constructors. You got me? The difference between peer zero and the rest is peer zero gets a configuration object passed to all the constructors. Because everybody else is constructed by joining the group. I'll do that.
So am I.
What are you doing?
Yeah. I was doing that. Kinda.
But it has other modules too. It has our private modules. It's better to keep it in XML file. But the XML file does, we'll leave the jar in the XML file. We'll point to the jar in the XML file. That's not a big deal. It's also starting the peer group. We should have the peer group information in the file too.
Yeah.
In the XML file.
That way you don't. Well, if you have the peer group information.
Okay, the XML file, we need the original jar, the application jar, no modules. We're going to ask for the modules. We need the parameters. We need an administrative jar, no modules.
That's the private. Right?
Yeah, that's the peer zero jar.
Alright, so the only thing public is the original jar and the parameters, right?
No,
No, the parameters are private too.
the only thing public is the
Is the jar.
original jar. I mean, is the application jar.
Yeah.
And the peer group and an associated jar. The peer group name and the associated jar.
Alright, so
Those two together start an application.
public.
Those two together start an application. A peer group with an associated jar. We know where the jar is because we're peer zero and we loaded the file while we were starting. We instantiate everything. The only difference between us and the rest is that we instantiate using configuration objects. And we also instantiate anything in the private jar. Also with configuration objects.
Which object in Pace starts up?
What's that?
Which object is doing that?
In Pace,
Yeah.
application is.
Application?
Yes.
Okay.
Right now, application is doing it because it takes the command line argument. But what we want it to be is we want it to be a user interface event. In other words, load this XML file. That XML file will point to the jar. We'll create the peer group. All right, what I'm going to do is the XML file. Restructure the XML file. Redo the parsing. I need an object that has the path to the jar. It has the peer group name. It has the parameters for the application. It has the private jar. It has this. It has this list in addition to the with the peer group name. No modules are needed. What that will do is that event is handled by network as well as application. In network, it will take the peer group name and the jar and advertise them.
If the peer group doesn't exist already.
It will not exist.
Oh, for this application. That's right.
Yes, yeah, the peer group for the application. Because by starting up the app in Pace,
I keep getting.
yeah, when we start up Pace, we join net peer group, which is generic for using Juxta, and then we'll also join Pace.
Do you need to join Pace?
Yes, because that's a set of services. That's
Okay.
the regular Pace services. And then from there, user interface, you'd say load perimeter sweep XML. Enter. That would create an event that is handled just by Pace.
Then the application peer group only has to be created. So then if it doesn't, then if it
What peer group?
Huh?
Pace peer group only has to be created
Yeah,
once.
application peer group
Exactly.
Yeah.
Because peer 0 is going to say load parameter sweep XML, which is going to have the peer group name in it, and that's going to go to both the network subsystem and the application subsystem. Network subsystem is going to say load or create a new peer group, and I also have this file jar, this application jar advertised as well. That's available as well. That's available, and so is the peer group. That's it. It's the only thing you advertise. Peer group name, jar.
Just for there are going to be a lot of threads on network, like listening for.
Well, yeah, I mean, there may or may not be a lot of threads. Even if it's single, it should be all right, because it's going to be queued. It's going to be going through a queue. So we advertise that, right? The jar and the peer group name. On the application side, application, if it receives a configuration object, it will find the jar, load up the application, the jar, ask it for its modules, instantiate all its modules, passing it the parameter object. It will also instantiate the whatever the private objects, and then it will initiate a start signal, and then it will start running. So, what happens on a peer that's joining? A peer that's joining will not say load parameter sweep XML. A peer that's joining will say join peer group whatever. Okay, we can even get fancy and say, hey, what peer groups do you have? I have parameter sweep, I have cure cancer, all that stuff, and I choose, oh, parameter sweep, that sounds interesting. It looks like they're adding numbers together. So I'll say join parameter sweep. When I join parameter sweep, the only thing that's advertised with that is the jar. I download the jar. I ask it for its modules. I instantiate its modules. I issue a start. I issue a start. I'm empty. I will ask for split. Somebody will give me back split. I will absorb. Right? So what do we need? We need those things in network, right? I need to create a peer group named this, and it has a jar advertised. If somebody joins a peer group named this, it gets the associated jar. All our applications will be joining a peer group that has an associated jar.
And this is some network object index.
Yes. The network stuff will do that, and when it gets a jar, what will it do? It'll emit a signal saying new jar. Application event queue itself will handle the new jar thingy event, right? And it'll grab that signal, take the jar out, whatever. It'll open the jar or whatever. All right. I'm gonna start listing all these bajillion signals that we've designed today on the wiki. Quit. We got ourselves an app, gentlemen.